Okay, so our couple of objectives that we have are going to be to understand and verify if a given point is a solution to a given equation. So that's one objective. Second objective is to find 3 ordered pairs of points that are solutions to an equation So we're going to talk about a chart, a table method to help you with that. And then you're going to graph 3 ordered pairs and connect. Okay, so generally when we graph ordered pairs, we're not graphing them in isolation and you just see 3 dots. We're going to actually be creating drawing an equation, and there's going to be all sorts of different kinds tonight, so they're not all going to be the same kind, but you're going to see a lot of the same kind. We're going to kind of focus the majority of our study on one type for a little bit. Let's see, what was the other thing? Review transforming an equation for a particular variable. And we did that earlier in Chapter 1. So one of the things I am going to do today is also take you to the online book where you can get extra practice on exactly the things that we're covering today. So I'm going to give you the reference for the online book, the Go Math. We are in Lesson 5.1, so Module 5, Lesson 1 in that. And I'm going to give you page numbers where you can find the Personal Math Trainer, and then I'll show you where they are. So the Personal Math Trainer is on page 120, and that one is dealing with the first objective. And then Personal Math Trainer on page 121 is going to be dealing with coming up with ordered pairs. So that's going to be 3. And then it probably is also going to deal with the second objective and the third objective. Okay? And the other objective, they don't have a Personal Math Trainer in. And there is one more Personal Math Trainer on page 123. Probably an overall one, because that's on the independent practice page. Okay, so those are the best places for help on problems, is to go to the Personal Math Trainer. Okay, and we'll try to get on one today as well. Alrighty, so let's go back to our beginning. Let's first do a vocab word. In the first objective, what's a word that you think we should define? Ordered pair. We did that in the last set of notes, right? We got that one down. Okay. What's a word we haven't written down, perhaps? Solution. So let's talk about that. So a solution is any... Now, let me ask you this. If I'm using an ordered pair, what are you going to find in the equation that we're solving? An x and a y. So we're going to have 2 different variables in our equation. So any ordered pair that makes an equation with the matching, all right, let's say it this way. We'll call it in 2 variables. Any ordered pair that makes an equation in two variables, and the two variables tend to mirror what we have on our graphs, x-axis, y-axis, tend to mirror what's in our ordered pairs, an x-coordinate and a y-coordinate. So I'm going to write here x, comma, y. Okay, they're both going to show up in your equation. So any ordered pair that makes an equation in two variables true. And remember, what makes an equation true is what's on the left side is going to be equal to what's on the right side. So same. Okay, and that's what we're going to be testing. You guys did a little bit of that. We talked a little bit of that before. And anytime that you've been solving equations, you've been using this notion, but we've only had one variable in the equations we've been talking about before. Okay? So looking at the third objective, what's a word that we should probably make sure that we're all on the same page and we understand?
Transform.
That's the fourth objective.
Oh.
Graph. Ian, graph. Yes, graph, that's a good one. So graph is just the, I like how they said it in this book, a drawing that represents the solution set. So it's a visual presentation I'm going to say drawing of an equation's solution. Once we introduce two variables, we often have an infinite number of correct answers. When we had one variable, we often had exactly one answer, though there were instances where there were no solutions when we got an answer like 5 equals 7. And there was instances when we had an infinite number of solutions, all real numbers, when we had something like x equals x or 0 equals 0, something that was always true. So we've had multiple types of answers we could get. But now we're going to take those ordered pairs, we're going to graph them, and that graph is going to be our solution. So there should be more than just a couple things. Okay, so let's start with the first objective, and we're going to determine whether an ordered pair is a solution to the equation. So we're going to answer this question. Is an ordered pair a solution to the equation? So we're going to have to be given two things. What are the two things they have to give us? They have to give us ordered pair. What else do they have to give us? Right. They have to give us an equation. So let's use this one. Okay. So what do you think you're going to do to determine whether the answer is yes or no? Okay, Amanda.
Plug in 3 to where the x's and 7 where the y.
Okay, now we're going to use a more mathematical term other than plug in. We're going to use the word substitution. Okay, so we're going to write down a couple things real quickly and then solve it. So we're going to substitute the x coordinate, and I'm going to abbreviate it as coord, for the x in the equation. We're going to substitute, that's a lot of t's in substitute, the y-coordinate for the y in the equation. So this is pretty common sense, right? Pretty much common sense. And then solve. If left value equals right value, the ordered pair is the solution. And I'm not going to write it, but the reverse would be true. If what's on the left doesn't equal what's on the right, then that ordered pair wasn't a solution. Okay, so we're going to go back to what Amanda said. Let's go ahead and take our ordered pair, the 3 and the x, and 3 and the 7, and identify who's the x, that's the 3, and who's the y. Remember, all ordered pairs are written alphabetically, x coordinate, y coordinate. And then we're going to take the x value, and we're going to plug it in where the x is in the equation, and we're going to plug the y value in for the y. And we're just going to follow that all the time. So what we have is the y value is, bless you, 7. And we want to know, does that equal 2? And then the x value was 3 plus 1. So this is our big question mark, because we don't know if that's going to be true or not. So we just start doing math. So nothing on the left side to do. We get 7. We follow order of operations, do multiplication first. 2 times 3 is 6. And we write out the rest of the equation. And then we add 6 plus 1 is 7. And we get what's on the left is on the right. So our answer would be yes. Bless you. 3, 7 is a solution of, oh my goodness, sneezy froms out here. Y equals 2x plus 1. Okay? Let's do one more. Oh, Amanda, yes.
On the test, when we get our answer, say it's another pair, do we put it in parentheses? Ordered pair.
Always the ordered pair has to be in parentheses or it's not an ordered pair. Okay? So there's three criteria about ordered pair. The numbers are in a specific order, the x coordinate, y coordinate. They're separated by a comma, so we can see where one number ends and the next number begins. Because we can have coordinates that are in the thousands, okay? Nobody likes to graph that, but we could have a number in the thousands. And then last, it has to be in parentheses, because otherwise we'll just think it's two random numbers. We don't realize, without the parentheses, we don't realize that they are together identifying the location of a point. Okay, so 3 things that we need to have for those. All right, let's try one more, same idea. So this time, let's try the ordered pair -2, 3. And let's try the equation 2y equals 4x minus 8. Okay. So we're just going to go ahead and do our substitution. 2 times our -3. Oh, -2, sorry. 2 times our -2. Remember, I went to bed like at 3. Sorry, try that again. See? Tired brain. I said it right, and then I wrote it wrong, and then center. Okay. Put in the y value for the y variable, so we're going to put the 3 next to the 2, because the 3 represents the y. And then we're going to have the 4x. And instead of x, we're going to write the x coordinate, which was the -2. So he goes in there. And then minus 8. So then let's go ahead and solve this. Now, one of the problems I'm seeing kids are having, they're making mistakes with signs. So really be cautious with your signs. So 2 times 3 is 6. Here the signs are different, so I'm going to get a negative. And notice I always put my sign in first before I do the math, so I don't forget about the sign. 4 times 2 is 8, and then I have minus 8. So I have nothing left to do on the other side. Now here the signs are the same. Just a little reminder, if you're having trouble dealing with how do I deal with the subtraction with the signs, do I add, do I subtract, I don't know. You can rewrite this as an addition problem by adding the opposite. So it's -8 plus -8, and hopefully that'll clarify, do I add, do I subtract. Signs are the same, so you are going to add, and they both are negative, so you're going to get a negative answer, and 8 and 8 is 16. So what we notice is that 6 doesn't equal -16, so our answer is -2, 3 is not a solution of 2x equals 4y minus 8. Okay. Now that's not to say there aren't solutions, just that ordered pair they wanted us to test is not. Okay. So next, let's go back and review our objectives here. So understand and verify if a given point is a solution to a given equation. Pretty easy, right? Done. We got that one down. So now, we need to find 3 ordered pairs of points that are solutions to an equation. So let's tackle that one. So what we need is an equation. And then here comes the fun part. You have your brain and you get to choose, okay? So what we want to do is to find three solutions of the equation y minus 3x equals negative 2. So I'm going to give you a huge hint here of what you should do. Huge, monumental, which means do it, okay? When we are trying to figure out what numbers to put in, this is the time where we want to use that notion of transforming. And I don't know if you guys remember last year, but you talked about writing equations a very specific way when you were dealing with equations with 2 variables. Does anyone remember what your equations were looking like with the 2 variables? Because you guys should have done this in your pre-algebra class. Say again? Well, what were you thinking? So one variable's on one side and the other one's the other side. Which one was usually by itself on the left? And I'm going to say you had a 50-50 chance, and you got the wrong 50. Typically, when you guys were dealing with equations last year, you were asked to get the y by itself. And we'll talk about more reasons, but when the equation has y by itself and everything else on the other side, it actually reveals a lot about that particular equation, okay? So what we're going to do, big hint, is you're going to solve the equation so y is alone on the left. It's going to make our finding 3 solutions a lot simpler, okay? Because it's going to help us kind of figure out what we're going to choose for an x. All right, Amanda.
Is this the problem where you get y on the left and you put 0 on the x?
That's not necessary on this one, no. But that is actually something we'll talk about this week, okay? So Amanda's talking about a way of graphing an equation. But that's not quite what we're up to yet, but we'll get there, okay? So what we're going to do is go back to our equation and ask ourselves, what do I need to do to y minus 3x so it's just y? What math am I going to do so that the variable y is by itself? Patrick. So we're going to do whatever math is happening to the y, we're going to do the inverse of it. So we're subtracting 3x, so we're going to add 3x. So remember with transforming formulas, doesn't matter if there's variables. It's the same idea. It's the same notion. Let's get rid of that term that is being subtracted. The opposite would be to add it. Now I am going to also recommend that you do something else, that when you solve this equation, that you always, regardless of the sign, put the x term right after the equals. And again, we'll talk why that's important, but not today. Once I do that, then I'm going to look at what's my coefficient of x, and that coefficient is going to kind of determine what kind of values I get to choose to plug in for x, and then I'm going to solve by substituting in the x value and calculate the y, and then create an ordered pair from that. Okay? So here's my suggestion. When you would graph, 0 is always a great number because he's easy to calculate with. You want a positive number and you want a negative number because you want your numbers to, your ordered pairs to get spread out so it makes a nicer graph. Okay? Personally, I'm going to pick the easiest numbers to work with. So outside of 0, what are the next easiest numbers to work with? Miles?
1 and negative 1?
Yeah, 1 and negative 1. Now, this is just a suggestion. You can pick any numbers you want, and you will get the same graph, the same picture of this data, but you just may have a different part of it. Like I may have this portion of it, you may have this portion of it. Okay, somebody else may have this portion of it depending on what they choose. And I'll give you an example of what if that coefficient is a fraction, how do we contend with that? So what we're going to do is practice making something called a table of information. So it looks like this. We put in x, that's going to be our choice. And then what we're going to do is rewrite the equation where it's been solved for y. And this is actually my work column. This is where I show all my work. The answer that we get is going to go into the y column, and then the last thing I'm going to do is put the x that I chose, the y that I got, and then I'm going to write it as an ordered pair. Now I'm going to share with you a couple key vocab. The numbers that I am choosing that I'm going to put into my equation, the x values, have another name. They are called domain. Domain is what I'm putting into this formula. So it's like a machine, it's like a computer. I stick something in, blip, 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 blip. I just think of Willy Wonka and them going through their weird little places, and all of a sudden they come out, or his little machines, and out comes that turkey dinner into the gum, piece of gum. And so what we want to know is, what do we call that piece of gum? What's the output called? So I'm also going to write a name here, input, because that's what people think of x. So y is the result of putting in the x, and he has a name called range, and you might refer to him as an output. But domain and range are the most common words. So you're going to be hearing me use domain and range interchangeably with x and y. Okay. All right, so let's go to our chart. My coefficient in front of the x is a 3, so I'm going to pick whole numbers because I don't want to create fractions, and I'm going to pick my three favorites, which are 1, 0, and -1. So I'm going to give myself some space here. Now what I'm going to do step by step is plug in each equation, or each number, into the equation one at a time and solve for y. So I go y equals 3 times, positive 1, minus 2, which gives me 3 minus 2, which equals what? What's 3 take away 2? 1. So I take the x, the domain I put in, and I take the y, the range I got out, and I make an ordered pair. 1, 1. Okay? Notice that I didn't write the answer in the middle. I wrote the answer in its own column. Okay? Next, let's try 0. So I substitute in 0 for x, and I solve. Well, 3 times 0 is 0. And what's 0 take away 2? Careful, what is it? -2. So my domain was 0, and my range was -2. So my ordered pair is 0, -2. Okay? I'm going to move up this -1 a little bit. Now I'm going to take the equation and this time substitute in -1 for x. So what's 3 times -1? -3, and then -2. And what's -3 take away 2? -5. Okay, so my input, my domain was -1. My output, or my range, was -5. Okay? Everybody get that? I saw some puzzled looks on a couple faces. Justin.
Wait, I don't get the very end, like how you did equals and then -3 plus -2.
I took the equation, y equals 3x minus 2, and the first thing you see is the x replaced with a domain value -1. Now I'm going to solve that equation, so it's still equal to y, but now I'm going to do the math on the right side. So 3 times -1 is -3, and then take away 2 is -5. Okay? All right, so let's do one where we might have something a little bit not so pretty. Okay, I got some uglies for you. Let's do one of them. So let's say that we've got this equation. Nope, I don't want to do that one. Hold on. Oops, go back. 5x plus 7y equals 19. This is mean, but I'm going to do it anyway. Yeah, this is mean, okay? Alrighty, so what is going to be the first step in transforming this formula so that y is all by itself on the left? Ian.
Subtract 5x from itself and 19.
So we're going to subtract 5x from both sides, which is the same as saying from itself and 19. And we're left with 7y equals, and again, get in the habit of putting the x term right after the equals, even if he's negative. We'll talk about y in a little while. All right, next, how do I get the y alone? He'll come back. Patrick? We're going to divide by 7, and that means everything gets divided by that 7. So we get y equals negative 5/7 x plus 19/7. Okay. Now, I'm going to do my graph, or my chart, and all I'm being asked is to come up with 3 solutions. The 3 solutions are what the last column reveals. Actually, I'm going to leave a little bit more room there. The answer will be the y, and the solutions are going to be from the last column. All right, so look at your coefficient in front of the x. What do you have? Brian? A negative 5/7. So what would be our smart choice to pick for my x values? Okay. If I pick negative 1, is that going to be a good choice? Okay. May not. Okay. So what would be a good choice? Maggie, saw your hand up.
Fraction with the same denominator.
And I'm going to say we're on the right track, but I don't want to pick a fraction. Okay, because graphing, if I can avoid fractions, it's good. If I can't, I have to deal with them. But, Brian?
Something divisible by 7?
Yeah, we're going to pick something that I can get rid of the denominator by. And what's the LCD in that equation? 7. So the big thing is to get rid of the 7 in front of the x. So what I'm going to choose are positive 7, a 0, and a negative 7. Okay, now, that doesn't mean we may not have fractions, but that's okay. This is just a suggestion, so I'm going to write a little note up here. When the coefficient of x in the transformed formula is a fraction, choose the denominator both positive and negative as an x value. What should be my third? And my third value is going to always be 0, right? Because he's easiest to calculate by. So when the coefficient of x in the transformed formula is a fraction, choose the denominator, both a positive version and a negative version, as an x value. Okay, so we've got negative 5/7, and just to highlight it, let's plug in 7 plus 19/7. Now this is totally ugly, however, you are going to have problems like this on your homework tonight. Now, notice that you have a fraction. Okay, notice that you have a fraction. So this isn't always going to be the case that you have a fraction coefficient and a fraction value. But because you have, we're going to do something slightly different because of the fact that the only way I can add fractions or subtract them is if they have matching denominators. So right now they do. So instead of canceling out the denominators in this coefficient, I'm going to go ahead and leave it and make it negative 35/7 plus 19/7. Now some of you might say, why didn't we just multiply by 1 then? And again, this is a unique situation that I ended up with 2 fractions. Sometimes you'll end up with 2 fractions, but they don't have the same denominator, and sometimes you'll only have 1 fraction in the coefficient. Okay. Sometimes you may have just a fraction in the the constant. So there's lots of different math you're going to have to do. So what we end up with is two signs that are different, bigger numbers, negative, and what's 35 take away 19? 16. So we end up with negative 16/7. So when you write your ordered pair, the input or domain was 7, and the output or range was negative 16/7. Now, when I'm graphing this, however, I am going to think about the fraction as a mixed number because I can't graph improper fractions. So 7 goes into 16 twice, which is 14 with 2 left over. And that's actually what I'm going to graph is the 7 and the negative 2/7. Okay? Now again, you have options. If both of them have the same denominator originally, then I would pick 1, 0, and negative 1. But because I'm trying to illustrate a particular idea, we're going to leave it like this. So here we're going to have y equals negative 5/7, and we're going to substitute in 0 for x, plus the constant 19/7, and we get 0 plus 19/7, and the answer is 19/7. This is why I love putting in zeros. So then I put in a 0, and I got out a 19/7. Now again, if I was graphing this, I would have to change the 19/7 to a mixed number. Alex, I don't see you writing anything. 7 goes into 19 twice, which is 14 with 5 left over. So 0 and 2 and 5/7 is what I'd be graphing as my ordered pairs. And then last one, we'd have negative 5/7, and then we're going to multiply it by our last choice, negative 7. And we're going to add 19/7. So again, because of the fractions, I'm going to keep the, I'm going to just multiply by negative 7 over 1. So two negatives make a positive. 5 times 7 is 35. So I get 35/7 plus 19/7. And that's going to give me 54/7. So my input or domain was negative 7. My output or range was 54/7. And again, if I was actually graphing this, I'd change the 54/7 into a fraction. So 7 goes into 54 7 times, which is 49 with 5 left over. So I'd be graphing negative 7 and 7 and 5/7. Now, when we're graphing, we just kind of estimate where 5/7 would be, so we just kind of have an eyeball on that one, okay? All right, so we have, let's look back at our, so we've done the first one, understand, verify if a given point is a solution to a given equation, snappy. We found 3 ordered pairs of points that are solutions to an equation. We have also reviewed transforming an equation for a particular variable. Let's do graphing. So again, best way to come up with your points is to go ahead and have the equation rewritten where y is by itself. So we're going to graph the solution of an equation. So what they're going to give us is an equation. So we could have y minus x equals 1. So again, it's not in the best strategy. So what would I need to do to get the y by itself? Miles.
Add x.
We're going to add x to both sides. And we get y equals x plus 1. So now I'm going to come up with my chart, and I'm going to do that on the left side here. And I have x, I have y equals x plus 1, so this is really where the work is taking place. I have y, and I have the conclusion of the ordered pair put together. So the coefficient of x is 1. So I'm going to pick my standard favorites, 1, 0, and negative 1. So I have y equals, and then I plug in 1. Plus 1, and 1 plus 1 is 2, so I've got 1, 2 is my solution. So my domain and range together make that ordered pair. And then next, I'm going to plug in 0, bless you, for x. And this is a really easy question because I had no coefficients, so I have very little math to do, and 0 plus 1 is 1. So The domain is 0 when the range is 1. And the range is 1 when the domain is 0. And then we have one more to try. Y equals, and then we're going to substitute in -1 for x. And what's -1 plus 1? 0. So when the domain is -1, the range was 0. Oh, that looks like a 6. Okay, now I'm going to add my fancy paper. And I'm going to graph this solution. So notice I don't have super big that I need to go to. I need to go to 1 and -1 on my x-axis, and I need to go up to 2 on my y-axis. So remember I talked about kind of making my graph go along with what information I have. Now, because my numbers are so small, I think what I'm going to do this time, and don't forget to label x and y, is instead of counting every mark of the paper as 1, I'm going to count by 2 boxes equal a 1. 2 boxes equal -1. And I have to keep that same pattern. And that's about all that I need, okay, for my particular graph. So I'm altering my graph to go with the data that I have to graph. You guys can do whatever you want on it. So then I'm going to graph my 3 ordered pairs. I go to from the origin to 1 up to 2, mark my dot. I stay at the origin, I go up to 1, and then I go to -1 on the x-axis, and then don't budge from there. And then what do? Is I draw a line through those 3. So this is what we call a linear equation, because the picture we get is of a line. And if you look at the first 3 letters of linear, it's the word line, okay? So that's what you guys are going to be working on your homework tonight.